Hi, let's look at some problems from section 3.5 homework, that is polynomial functions and graphing them and finding key parts to their graphs and answering some questions about how the function might be increasing, decreasing, and so on. So I've selected a few problems from my math lab. In section 3.5 number 11, it says given the following function, find the y-intercept and the intervals where the function is increasing and decreasing. Well, to find the y-intercept, we just plug in 0, right, for x. So the y-intercept would be 0 cubed minus 4 times 0 squared plus 0 plus 4. So the first three terms go to 0, and 0 plus 4 is 4. So the y-intercept would be the point 0, 4. Then it asks you to find where the function is increasing and decreasing. To find where the function is increasing or decreasing, you need to know the turning points or the relative max or min. So I've already done that on the graphing calculator, and if you watch the graphing calculator video, you'll see how to find the relative max or min. But what I've found are the ordered pairs for those turning points. And so we find that the graph is increasing as we go up to this maximum point, and then it's decreasing, and then it's increasing again. So we need to know what the x values are for these 2 points. We know this x value is 0.13, and the x value for this point we found over here is 2.5. So the graph is increasing on the interval from negative infinity to 0.13, and then also from 2.5 to infinity. Now, you'll need to read carefully on the My Math Lab to see how many decimal places it tells you to round that value to. I've rounded it to, well, I did differently here, either 2 or 1, but if it says to do 2 decimal places, I would need to have put 2.54 over here. I'll go ahead and do that. Now, where is it decreasing? It's decreasing where the graph is going down from left to right. So that is on this piece, which is between which x values? Yeah, between 0.13 and 2.54. So remember, for answering where is it increasing or decreasing, you're always doing the intervals of x. Now, it says to find a comprehensive graph for the following function and find the x-intercepts and the y-intercepts. So in y1 on my calculator, I input this ugly function. And then it says to find which of the following windows will show a comprehensive view of the function. Well, this is where you basically just have to go through on the calculator and enter these different windows to find which one gives you the comprehensive view. And when I entered the values for A, that did not work, and then I tried C, actually went down, and this one actually did work. You see, if I did -5 to 5 and used an x scale of 1, and then -300 to 400 with a scale of 100, and this is the graph that I found. So that shows a comprehensive view. Comprehensive view, remember, shows all the intercepts, all the turning points, and that is the case for this one. Concept check. This is from your book. It says use the graph shown here and answer the questions from 5 through 12. So we'll go through some of these. It says in number 5, use the extrema to determine the minimum degree of f. Okay, so the minimum degree of f, how many turning points is it? Okay, so we have, what, 1, 2, 3 turning points. So do you remember that there are always n-1 turning points at most? So n-1 in this case would be equal to 3, which means that n could be 4. It could certainly be another even degree like 6 or 8, but the minimum would be 4. Okay. Use the extrema to determine the minimum degree of g. Well, here's g. We have how many turning points? 1, 2, 3, 4. So in this case, if n-1 is equal to 4, the degree could be 5. Give all local extreme points of f. Tell whether each is a maximum or minimum. So the extreme points of f would be A, B, E, I can't even tell what that is, E, T, and C, D. So A, B, and C, D would be maximum points, and E, T is a minimum. The local extreme points of G, well, we have what? NP and JK are max. Now remember what it means to be a max. In an area, it's the highest point. It's a peak. And the minimum would be RH and LM would be min. Describe all absolute extreme points of f. Well, absolute extreme means it's the highest point of all, right? Of the entire graph, or the lowest point of the entire graph. ET is not the lowest point of the entire graph because this function goes on indefinitely in the downward direction. So the local or absolute extreme points would be, I think AB is the highest point. That looks to be above that point. So AB would be the absolute max. Describe all absolute extreme points of G. Well, actually, this one has none because it goes indefinitely up and down, surpassing these peaks and valleys that are inside the graph. Give the local and absolute extreme values of f. So the values mean the output values. So the local and absolute extreme values of f. So the local max would be D. The local min would be T, and the absolute max would be B. The local and extreme values of G, so the local max would be P and K, and the local min would be H and M, and there are no absolute extreme values. Well, if I could spell this right, sorry about that, extrema. Now, without using a calculator, it says to match the function with the correct graph. So remember what we have to look for here is really the end behavior. So notice in number 37, its degree is 3, and it has a positive leading coefficient. So that resembles the graph of x cubed, which at the ends looks something like this. So the only one that does that is D. So this would be for number 37. 38 is a negative leading coefficient on a odd degree. So it's going to look like this, which would be C. 38 is an even degree function with a negative leading coefficient, so its end behavior is down. So that is number part B. And by process of elimination, we know that A has to be for number 40, but that is true because it's 2x to the 4th, which has an up on its end behavior, which is exactly what this graph shows. Okay, so I'm going to go through the calculator on another video. If you have any questions, don't hesitate to contact me. Thanks.